Hi friends, today we are going to discuss area under curves. This is an application of definite integration. Area under curves. Now the problem can be asked in three different ways. Number one, area under a curve and x-axis. Number two, area under the given curve and y-axis. Or area under two different curves. Area under curves and x-axis, area under another curve and y-axis, and area under two curves. So let us see the different situations pertaining to these three types. Let us first see area under curve and x-axis. Suppose we are given a curve like this and we want to find out the area bound by the curve between the two coordinates, say x equal to a and this is say x equal to b. Okay, the first step is to take a strip such that one end of the strip lies on the x-axis and other lies on the curve. The upper should lie on the curve here and the other end lies on the x-axis. So this is a strip that we are taking. You can see that the horizontal distance of this strip width will be dx and the vertical width will be y. Approximating this to a rectangle, the area of this particular strip turns out to be y dx. Now we are interested in finding this entire area. We want to find this entire area. So you can move this strip from this end to this end. That will cover the entire area and you can integrate it. So the total area will be given by y dx, and please note that since integration is with respect to x, the limits will be from x equal to a to x equal to b. Now let us see area under a curve and y-axis. Suppose you are given a similar strip, similar curve, and you want to find out the area between bound by y-axis and the curve between the coordinates, say y equal to a and y equal to b. In this case, you should take a strip in such a way that one end lies on the curve, other end lies on the y-axis. So when you take such a strip, you can see that the width of the strip will be along y-axis, so it is dy, whereas the length is along x-axis, so it is x. So area of this strip becomes x dy. And since we are integrating with respect to y, the limits of integration will be from y equal to a to y equal to b. Now the third type will be area under two curves. Suppose you are given one curve like this and another curve like this. So this curve represents y1 and the lower curve represents say y2. It can be having any equation. Now you want to find area between these two curves, so you want to find this area. So one end of the strip must lie on one curve, the other end must lie on another curve. Now the required area will be given by y1 is the upper curve minus y2, which is the lower curve. So it is y1 minus y2. And suppose after solving the two equations simultaneously, you get the point of intersection as, say this is x equal to a, say this is x equal to b, then the limits will be from a to b. Sometimes it is necessary to take a horizontal strip when you are asked to find area under a curve, it depends upon the situation. So let us consider another situation like this. The two curves given are like this. Suppose. Now if you take a vertical strip, what will happen? Over this region, the strip will start and end on the same curve. Again, as you cross this particular point, again the strip will lie on some other curve. So in this case, taking a horizontal strip, vertical strip, is not going to solve our problem. So it becomes necessary to take a horizontal strip. So when you take a horizontal strip, you can obviously see that one end lies on one curve, other end lies on the other curve. So now the area of under this curve will be given by, now it will be x dy and not y dx, because the strip is horizontal, the width is dy. So it is x1 minus x2 dy. Whereas this curve represents x1 equal to some function of y, which is the right hand side curve, and this represents, say, another curve x2, which is g of y. Please remember, it is always right hand minus left hand. When you take a vertical strip, it is upper minus lower. So these are the different types of problems which will be asked in the exam, and based on this now we are going to solve certain examples. Let us see the first example. Find the area bounded by the curve y equal to 2x minus x square and x-axis. Now this curve is a parabola. Please note that if the power of x is even, the curve is around approximately supposed to be symmetrical about y-axis. But first of all, please understand that this is not a standard parabola x square equal to 4ay. So what we have to do is, we have to actually bring it in a standard form. So let me try to bring this in a standard form. Please learn how I am doing it and see it carefully. First I will keep sign of x square as positive, so I will transfer it on this side. So I have x square minus 2x equal to minus 1. I brought everything on this side. Now I will complete the square. What is the last term of this square? X square minus 2x plus 1. So I will add 1 on this side. I will add 1 on this side also. That gives me x minus 1 bracket square equal to minus of y minus 1. Now this is in the standard form, capital X square equal to minus y. And what are the vertices? What is the vertex of this curve? The vertex of this curve is given by the origin in the new system, that is x equal to 0 and y equal to 0. So if you put capital X as x minus 1 and as x equal to 0, the vertex will be, you can see 1 comma y. When you put y minus 1 as capital Y and x minus 1 as capital X, x equal to 0 and y equal to 0, which gives the vertex, obviously gives you x equal to 1 and y equal to 1. So the curve is having a vertex 1 comma 1 and it is of the type x square equal to minus y. The next step is to find where the curve cuts x-axis and where the curve cuts y-axis. So let us see that also. To find where the curve cuts x-axis, you put y equal to 0. So you will get x minus 1 square equal to 1, isn't it? Put y equal to 0. So take the square root, it will be x minus 1 equal to 1, or x minus 1 equal to minus 1. That gives you either x equal to 2 or x equal to 0. To find where the curve cuts y-axis, you have to put x equal to 0. So if you put x equal to 0, you will get minus of y minus 1 equal to 1. Or you get y minus 1 equal to minus 1, and that gives you y equal to 0. So what are the coordinates of the curve meets x-axis at 1, 0 and also at 2, 0. The curve meets x-axis at 1 and 2, and the curve goes to and meets y-axis at 0. Based on this information, we are going to draw the curve. Now see how we draw the curve. What information we have? The information we have is that the vertex is 1, 1. The curve is of the type x square equal to minus y. It cuts x-axis at x equal to 0, x equal to 2, and y equal to 0. So this is the vertex. The curve cuts x-axis at x equal to 0, y equal to 0. 0, 0 is one point on the curve. 0, 2 is another point on the curve. 2, 0. And x square equal to minus y is dipping down, as you know it from your 11th standard exercise. So the curve will be something like this. Now you want to find this area. Now it's very simple. Take a strip, use the formula y dx, and the limits of x will be from 0 to 2. You can write y as 2x minus x square. Integrate this expression and you will get the answer. The answer turns out to be 4 by 3. Please check it yourself. Please see, I have repeated this. The 2 points are x equal to 0, x equal to 2, and y equal to 0. So in this way, you can get the answer. The answer is 4 by 3. Let us see another example now. Find the area of the region bound by y square equal to 2y minus x and y-axis. Again, I am going to repeat the entire procedure, but I am not going to solve it fully. You have y square minus 2y equal to minus x. Complete the square. You get y minus 1 bracket square is minus of x minus 1, which is of the type y square equal to minus x. The vertices are 1, 1. Now find where the curve meets x-axis. Put y equal to 0. You get x equal to 0. So 0, 0 is 1 point. Now you put x equal to 0. If you put x equal to 0 here, you get y minus 1 square equal to 1. So y minus 1 is 1, or y minus 1 is minus 1, and that gives you value of y as either 0 or 2. With this information, we can now draw the curve. So what is the information we have? We have the curve whose nature is y square equal to minus x, whose vertex is 1 comma 1, and it passes through the points 0 comma 2 and 0 comma 0. So let us draw the curve now. Passes to 0 comma 2, 0 comma 0. So this is 0 comma 2. One comma 1 will be somewhere in between. Since it is y square equal to minus x, the curve is towards the left. So this is how the curve will look like. Now you take a strip. Since the strip is horizontal, the width is dy. So you integrate x dy, and the limits of y will be from 0 to 2. All you have to do is substitute x as 2y minus y square over here. Integrate. You will still get the answer as, check your answer. The answer is 4/3. Now let's see area between parabola and a line. We are given a parabola. We want to find the area between x square equal to 4y and the line. First thing when there is area between two curves is to find the coordinates of intersection. So let us put 4y as x square. Let us solve these two equations simultaneously. So we have here x square equal to, this 4y can be written as x square. Sorry. X equal to, this 4y is x square minus 2. That is, to solve this, we get the 2x coordinates as x equal to 2, x equal to minus. Now substitute this in this line. If you put x equal to 2, you will get y equal to 0. Sorry, y equal to 1. Put x equal to 2 here, 2 plus 2 is 4, 4y equal to 4 gives you y equal to 1. And if you put x equal to minus 1, you will get y equal to 1/4. So these are the coordinates. One is 2 comma 1, another is minus 1 comma 1/4. You can also find where the line cuts x-axis and where the line cuts y-axis. Line cuts y-axis, put x equal to 0. Line cuts x-axis, you put y equal to 0. So line cuts x-axis at x equal to minus 2. With this information, we can draw the situation. Let us draw the situation here. We have some space. First of all, x square equal to 4y. Curve like this. What are the points? X equal to 2 and y equal to 1. Somewhere over here. X equal to minus 1 and y equal to 1 by 4. This will be x equal to minus 2. So line will be like this. This point represents x equal to minus 1. This point represents x equal to 2. Now take a strip in such a way. One line lies on one curve, other lines on the other curve. So it is y dx. What is y for the line? Y for the line is x plus 2 upon 4. And y for this is x square upon 4. So upper minus lower, and limits of integration will be from minus 1 to 2. Integrate this expression. And you will get the answer. Answer for this problem is 9 by 8. Please check the answer. Okay, let us do one more sum and we'll pack up with this session. Find the area bound by curves. There are 4 lines given. Y equal to is a parabola and 3 lines. X equal to is y-axis. So let us first sketch the plot. We have y equal to x square plus 2. That gives you x square equal to y minus 2 of the type x square equal to y, and the vertex is obviously x equal to 0, comma 2. So this is the vertex. Where does the curve cut x-axis? Put y equal to 0. If you put y equal to 0, you get x equal to minus 2. X square equal to minus 2 is impossible situation, so the curve doesn't cut x-axis. Where does the curve cut y-axis? Put x equal to 0. The curve cuts y-axis at 0, comma 2. So vertex and where the curve cuts axis are the same points. Okay. Let us try to find the point of intersection of this and this. Let us put y equal to x. You get and you can see that this has no solution. So the line y equal to x never meets y equal to x square plus 2. They are two different curves. They never meet each other. So with this information now, we are ready to draw the, can go to the next page. You can keep this for your reference. we have a situation x square equal to y, which is a curve like this. The line y equal to x never makes it. So this is the line y x equal to x. X equal to 0 is the y axis. Which is this. And x equal to 3. Now since this is 0, 2, x square equal to 3 will be somewhere over here. Obviously, since y is equal to x, this point will be 3, 3. Now we have to find the area between these regions. So this is the region that we are looking at. This is the region we are looking at. Mistake. X equal to 3 is parallel to y axis. Sorry, my mistake. This is not x equal to 3. Just a second. And this is y equal to x. So this is the region you want to find. You can see that if you take a strip, the upper end lies on the curve, the lower end lies on the line. So the area of indication will be y is equal to x square plus 2. So this is minus lower region is lying on line y equal to x. Indicate this between the limits. You can see limits are x equal to 0 to x equal to 3. And the answer of this is 21/2. Please check the answer. I think that is enough for this session. We can continue in our next session.